Aloha and welcome to this video for multiplying complex numbers. Our learning target is to multiply those numbers that have i's in them. Okay, so some special things to know about I. First of all, square root of I equals, I equals the square root of -1. I was getting ahead of myself. Okay, so we have imaginary numbers because back in the day, they needed to solve problems that have square roots of negative numbers, but they couldn't. They thought it was impossible. So they're like, okay, let's make a way to be able to figure these out. So to get rid of negatives, we have imaginary numbers. Okay, so to get rid of negatives under square roots. So the next thing that's important to know that we're going to use here, what is the value of I squared? Well, remember what it means to square something. It means to do I times itself. Right? Something times itself is how you square it. Well, we know the value of I. It's the square root of -1 times square root of -1. But we have a special rule here. A square root times itself, well, the square root cancels and we just take the value underneath and it's a -1. So the moral of the story here, to kind of make it a little easier to look at, I squared equals a -1. Okay, so we're going to use this fact here in a second. So let's actually do some multiplication. Yeah, here we go. So I need to distribute the 6 to this complex number, 3 plus 5i. So I'm going to distribute it to both parts, the real part and the imaginary part. So we're going to just multiply like normal. 6 times 3 is 18 plus 6 times 5 would be 30 with the I attached. Okay, all right, and that's it. That would be my product. Pretty simple example. Okay, let's try this next one. Ooh, this time we're kicking it up a notch. We're not distributing a real part, we're distributing an imaginary part. So what will we get when we distribute 7i to 2? Well, multiply 7 times 2 and you get 14i. Okay. Distribute 7i to that 3i. So we're going to have minus 7 times 3 is 21. But how many i's are there? We've got this I times that other I. So we have 2i. So we would write that as I squared. But you should never leave I squared in an answer because we know what it is. We know that it's a -1. So really we're doing 21 times a -1. So we're supposed to be subtracting a -21. So take a look. I think this is the easiest way to think about it. Whenever you have an I squared, scribble it out. It's completely gone. And change the sign. So it was a -21, so now we're making it plus. And then that will take care of you. Now the only thing we talked about, I believe in my my adding and subtracting complex numbers video, there's this standard form of complex numbers, a plus bi. Is my answer in standard form right now? Well, no, it's a little lacking. So we should flip-flop things. We should make the positive 21 be first, and then plus 14i, because the imaginary part is always supposed to be second. Then we'd be good. Then we are good to go. All right, maybe we'll look at one more of these, okay? So I can distribute again. So this time I'm going to get a -10i because 10 times -1 is -10. And then here I'm going to do 10 times my 8, so I'm going to have minus 80. And I've got 2 i's, so I'm going to have I squared. But never leave I squared in your answer. We know that this is just going to change the sign of 80. But then I've got to flip-flop the order so I'm in standard form. So positive 80 first, minus 10i. Nice. All right, let's kick it up a notch. Whoop, whoop. Ooh, I'm supposed to foil these guys. Yikes. So if you have your own way of foiling, that's cool. Arrows, or you write out FOIL, whatever. A lot of you seem to like the box when we did the radicals. So we can still use the box with these guys. And here's how it works. 3, 5i negative 2, 7i. Okay, so just multiply the numbers to fill in. 3 times negative 2, negative 6. 3 times 7, 21, keep the I attached. 5 times negative 2, negative 10, keep the I attached. 5 times 7, 35, but I've got 2 i's, so I'm making it I squared. Okay. Scribble out the I squared, make your 35 negative. Then we're going to add like terms. I'm going to start with the real stuff because that needs to go first in my answer anyway. So negative 6 plus negative 35, negative 41. And then 21i and negative 10i, positive 11i. Okay, I'm just combining like terms, so don't make it I squared. We're not multiplying anymore. We're just adding. So I would get simply 11i. All right, hot diggity dogs. We got a couple more here. Some foiling ones. Again, let me make my box real quick. Yo, Baba. All right, so 4, negative 3i, negative 7, 9i. All right, so I'm going to go quick with my multiplication, all right? 4 times negative 7, negative 28. 4 times 9, 36i. Negative 3 times negative 7, 21 positive with an I attached. Negative 3 times 9, negative 27, but then I have 2 i's, so I'm going to make that I squared. But cancel that I squared out and make it a plus. Oh, yeah. So then add these regular numbers together. Negative 28 and a positive 27 would leave me with a negative 1. And then 21i plus 36i, what would that be? That would be 57. Oops, I forgot to change colors. Sorry. 57i. So all together, that would be my answer. Nice. One more. All right. Do my square grid. Negative 3i and negative I, negative 7 and 9i. Multiply. So negative times a negative, positive 21. Negative times a positive. So it would stay negative 27 with the I attached. Oh, a negative times a negative, positive 7i attached. Negative times a positive, negative 9i squared, because there's 2 i's. However, the I squared is going to cancel and it's going to turn into a plus 9. Woo! So add my regular numbers together here. 21 and 9 would give me, a 30. And then 7i, negative 27i, and negative 20i. So minus 20i. Whoop, there it is. All right, so no preview questions for this video because it was just a lesson of what we did in class. So I will see you next time. Make sure you finish the homework. Keep learning, have fun, and I will see you the next time. Aloha.